So this video is going to be talking about chemical bonds. And so we are going to have different kinds of bonds that we're going to be looking at, but we are going to put an overarching theme. Bonding involves electrons. So that is why we spent so much time on the electron the past couple of units, is because all bonds involve electrons. That's where all of the chemistry is. So we're going to talk about three different kinds of bonds: ionic, metallic, and covalent. Ionic are going to involve ions, hence the name. Metallic are going to involve any element that is a metal. And covalent are going to be non-metals. So quick review: ions or ionic compounds, again, are going to have a plus or minus charge, a cation or an anion. Metallics are going to be on the left-hand side of the periodic table. Covalents, non-metals, are going to be on the right-hand side. The reading we're going to have you do is in Chapter 7. It's a PDF from an old book that we used to use that kind of summarizes ionic and metallic bonds. And then we're going to have another chapter, Chapter 8, another PDF for you to read that's going to give you the background information on covalent. We're going to spend most of our time on covalents because they require the most discussion, most practice, so on and so forth. So we're going to start with ionics and move to metallics and then go to covalents. So again, bonds are involved with electrons. So the only bonds, or excuse me, the only electrons that are involved are the valence electrons. So these are the ones that make the bonds. So the innermost electrons never get involved in the chemistry. So valence electrons, remember, are the electrons in the highest energy state. Okay. So we will be looking at a couple practice problems here for you to identify the highest energy level. And this is, again, those are the electrons that determine all of the chemical properties of an element. So that is why chemists worry about the valence electrons. They don't worry about the innermost electrons. And hopefully by now, you have realized that there is some kind of pattern to electron configurations. And the big pattern that you should see is the fact that noble gas configuration that we were doing in the last unit involves 8 electrons. So it involves, again, what we call the octet rule, octet meaning 8. So all atoms tend to make the electron configuration of noble gases when it can. So 8 electrons, again, is going to be 2 in the s orbital and 6 in the p orbital. So that is why we usually deal with what we call the representative elements, the first 2 columns on the periodic table and the last 6. I will be showing you some examples of the transitions, but for the most part, what you're trying to do is get the magic 8. So electron configurations, okay, we just talked about those, but to kind of summarize or paint a picture for you guys. If I am looking at the noble gas configuration of phosphorus, I look it up on the periodic table. I write neon, and then 3s2, 3p3. And again, we've spent a lot of time on that, so I'm not going to pause here and go over that one more time. But when phosphorus makes an ion, it makes an anion. It makes a -3. So that means it has gained 3 electrons. It has gained 3 electrons. Well, where are those electrons going to go? So you should start to look at the electron configuration and see some patterns to it and see that the p orbital has 3 electrons in it currently. If it adds 3 more, it will then have a p6, which is the magic point. That's your octet rule. So I could write it as neon 3s2, 3p6, or I could write it as, of course, argon's electron configuration. It does not mean it becomes argon. It means it has the same number of electrons as argon noble gas. We could also look at the left-hand side of the periodic table, something like magnesium. If we write its electron configurations, magnesium neon 3s2. Well, again, it wants to make a p6 if it can. Well, on the left-hand side, the metals on the left-hand side, they tend to form cations. So magnesium, remember, is the second column of the periodic table, so it's a +2. But what you should start to put together here is, well, an easier way to get to a noble gas, instead of going all the way to argon, is if I got rid of these 2 electrons in the 3s orbital, I would then have the noble gas of neon as my electron configuration. So what you will see me do on occasion is I'm going to write out the electron configuration of the element, and then I'm just going to cross out the electrons from where they came from so that you know where they are. So magnesium 2+ is neon. Again, it's going to have that magic 8. It's going to have that 2 in the S and 6 in the P. So again, that's kind of review from the previous chapter, but here's going to be kind of the newer information. So we have the transition metals in the middle of the periodic table, one of them being manganese. If I were to write its electron configuration, it would be argon 4s2 3d5, okay, by where it is on the periodic table. Well, what we're going to ask you to do is not just do the electron configuration of the element, we are also going to have you do ions. So manganese actually makes 2 different ions, and you don't need to know or memorize that it's a +2 and a +3. That will be given to you. But here is where we're trying to stretch you a little bit. I am losing 2 electrons. So the transition metals always become cations, so they become a positive charge. So they're always going to lose electrons. They're always going to lose electrons. So here's the tricky part. When we fill the electrons, the 4s fills before the 3d. But when we're talking about forming a cation, the energy level, that 4s is actually a little higher energy state than the 3d. Even though the Aufbau diagram kind of shows the 3d a little bit higher, the electrons actually come out of the 4s before it comes out of the 3d. And that's because the d orbital is a very complex structure. S being a sphere, it's just easier to take the electrons out. So manganese, I'm just going to rewrite the whole thing again, and then I'm going to show you what I'm going to do. So I have a +2. So I have 2 electrons that are coming out of the 4s. So my electron configuration for manganese 2+ is argon 3d5, argon 3d5. Well, what if I had manganese 3+ instead? So instead of going all the way back, I'm going to go to my manganese 2+ here and go, okay, I actually have 4 electrons in that d orbital now. So again, I've taken 2 out of the s orbital and 1 out of the d orbital. So this is with the transition metals, these are always a little more tricky in terms of how they make ions. So I'm going to give you cobalt. Okay, I'm going to give you cobalt. So I want you to pause the video right now and see if you could do cobalt. And cobalt has 2 charges, cobalt 2+ and cobalt 3+. So see if you could write the electron configuration. So the correct answer for cobalt is argon 4s2 3d7. Cobalt 2+ is argon 3d7 because you've taken the 2 electrons out of the 4s. And then cobalt 3+ is argon 3d6. So that is, again, kind of a quick review or a beginning part of what we're talking about in terms of electrons.